Alrighty guys, today you talked about rates, unit rates, ratios in class, and tonight we're going to talk about something called the constant of proportionality. But before we get into that, let's talk about what it means to be proportional. It is said that two quantities are proportional if the ratio between the quantities is equal. Now we're going to keep that in mind as we work through today. Everything highlighted in blue are things that we're going to skip, just so that you know. And we're going to jump right into it. The constant of proportionality is our new vocabulary term. And what it is the value of the ratio between two proportional quantities. Now, if you're like, Miss Carbone, I don't know what proportional means. Proportional means that, like, one depends on the other, they work together, and they start at zero, basically. So think about money spent and items bought. The more items you buy, the more money you spend. But if you don't buy anything, you don't spend anything. So the constant of proportionality here is the value of the ratio of two proportional quantities. The constant of proportionality is represented by the equation of k equals y over x. Now, just so you know what these variables represent, we'll pop down here. The k is our actual constant of proportionality. The y's refer to the y values in a table, y values in table or graph. The graphs we'll work with later. The x is the x values in a table or graph. So our constant of proportionality is this very special ratio, and we use the letter k to represent it. Now, if we look at our first example here, we can see that it's asking us to examine our table below and describe patterns that are true. Based upon what we just talked about, you know that this fraction y over x is really equal to k if we're talking about a proportional relationship, which for our purposes for the next couple of days will only be proportional relationships. So let's think about this. We're talking about feet and inches. You guys already know how to find how many inches are in a foot, and you already know that you multiply by 12. Well, let's make sure of that. So for our first fraction, we're going to have y over x, which would be 12 over 1, which simplifies to just 12. Our next set, we have 24 over 2, which simplifies to 12 over 1. That's 21. 12 over 1, which is also just 12. Get where I'm going with this? Let's keep it going. 36 over 3. Let's skip the in-between step here, guys. 36 divided by 3 is 12. And let's do our next one. 48 over 4. Guess what that simplifies to? 12. Are you shocked? I hope not. And our next set, we have 60 over 5, which shockingly simplifies to 12. Now, this should not come as a surprise, because we all know that 12 inches are in 1 foot. But this is how we would test for proportionality, is we would check all of the ratios of y over x and make sure that they're all the same number. Once we've determined that they're all the same number, we can safely say that yes, this has a constant of proportionality, and that constant of proportionality is 12. So let's look at the questions that it's asking us. A, how do we know that the number of feet is proportional to the number of inches? We know this. We know that it's proportional because each set of data, each XY pair, right, has the same ratio of y over x, which we now know when that happens, when all of these purple numbers are the same, it is proportional, and our constant of proportionality is that number. Using x, the number of feet, how do we find y, the number of inches? Well, if we take our constant of proportionality, we say, okay, well, this is our constant of proportionality. So we have 1 times 12. As we all know, that's how you find how many inches. Well, what's 2 times 12? Well, that's 24. How about 3 times 12? Surprise, surprise, 36. And 4 times 12. And that's 48. So basically what you can do here is you can take your x, you can multiply it by your k to give your y. So x times k equals your y. Simple way to find it in a table and use it in a table. Now you can say that in however which way you like for part B, but most simply is we would multiply our x by our k to get our y. Multiply our x by our k to get our y. All right, let's use this information to go to our first example. We're not going to do part D of here, and we're going to do the questions slightly out of order. So it says, while training for a marathon, Keith's watch reported how many calories he burned at each mile marker. The data is shown below. Our first question, A, says, is the number of calories proportional to the number of miles? Explain our thinking. Well, we just looked up here. This is what we need to do to decide if we're proportional. We need to check to make sure the ratio of y over x is the same for every single point. So I'm just going to extend our table here so that we have like another whole row. And this row will be our test row. It'll be y over x. Just so you are aware, when you're talking about a table, typically your x is on top and your y is on the bottom. That is because the number of calories you burn depend upon how many miles you run. The more miles you run, the more calories you burn. So let's start checking it. I'm just going to zoom in here so I have a little bit more space to write. So we have for here 117 over 1. All right, can't be simplified. For our second one, we have 234 over 2. Check it. Do the division, it simplifies to 117. Do I have to put the over 1? No, I don't. I don't have to do the over 1 here either. I could have just said 117. So let's check it. 351 over 3. Do the division, and you'll see it simplifies to 117. 468 over 4, which would be 468 divided by 4, simplifies to 117. 585 divided by 5 simplifies to, shocker, 117. So all of our ratios are the same here. Every single time we did our division, we got the same answer. That means that yes, these are proportional, and our constant of proportionality would be this ratio of 117. So when it asks us, is it proportional? Our answer would be yes. Yes, it is proportional because each ratio of y over x is the same for every point, x comma y. Or you could say when you did the division for each set, you got the same answer. Now we're going to pop down here to 2 because we've already answered it, essentially. What is the constant of proportionality? The constant of proportionality is that ratio you get. So in this case, the constant of proportionality would be 117. Now part B says the next day, Keith ran 7.5 miles. How many calories did he burn? Let's think about what we set up here. We would multiply our x by our k to get our y. I'm going to grab that, and I'm going to copy it and bring it down here to help us with this one. All right, so it says we would multiply our x by our k to get our y. Well, we know x is our miles, so we know we have 7.5 miles, so we would do 7.5 times our K, which is 117, and this would give us our answer of blank calories. I'm just going to put CAL for calories. So 7.5 times 117 gives you an answer of 877.5. So in 7.5 miles, if you run 7.5 miles, he burns 877.5 calories. Hopefully it's making sense. If it's not, we're here for you tomorrow. All right, and each of these tables, it is your job to find the constant of proportionality. All three tables are proportional, so we're not asking you to determine if they are proportional, but simply tell us what the constant of proportionality is. So for the first one, you would do 6 divided by 1.5, which gives you 6 divided by 1.5 gives you 4. Second one, you do 16 divided by 4 gives you 4. 22 divided by 5.5. If you do it in your calculator, you'll see you also get 4. And then we have 30 divided by 7.5. Throw it in your calculator, and you'll see you get 4. This number that shows up in every single one is that very special number called our constant of proportionality, or K. So K is 4. Pause the video and try the next two tables, and in a minute you'll be able to see all your answers and compare. Alrighty, check your answers, see how you did. If for this one you had an answer of 3/2 for each one, you're still correct. 3/2 is still good, 1.5 is still good. Alright, now we want you to summarize this lesson in your own words right here, and we'll talk about it tomorrow. Tomorrow we're going to take it one step further by introducing you to a new equation. Thank you guys. Have a great night.